Hey, hi, good morning, good afternoon, good evening to all from wherever you are attending. First of all, I want to extend a very warm welcome to you all to this fireside chat. I am Sundaresh Shankaran. I am president at ITC Infotech. I manage an offering called Product 4.0. Through this offering, we partner with our customers to conceptualize, design, develop, industrialize, and distribute their products. We also help them implement various solutions like product lifecycle management, manufacturing execution system, manufacturing operations management, and supply chain systems. Today, we are here discussing a topic that we think is relevant for any product development professional, that too, who is involved in development of very complex engineered products. As some of us in this area know, products are becoming complex by the day. Development timelines are getting crunched. Customers expect more and more functionality. The regulatory, safety, reliability requirements are increasing. Given this, how are engineering organization managing this? And over and above this, the engineering teams are also getting globally dispersed. Organizations today are partnering with ecosystem of partners to develop the product. So in this context, today's chat, we have Mahesha Udipi, who is the chief consulting engineer at Baker, to share his perspective and experience. Actually, it's my privilege to introduce Mahesh. Mahesh has over 30 years of experience in the industry. I would say is a through and through product design, engineering, R&D professional. He has been with the oil and gas industry for the last 20 plus years. In his current role, he is responsible for many things. His area and portfolio is well completion equipment and tools. He is responsible for evaluation of safety, quality, regulatory compliance of these products. He provides technical oversight to complex issues like qualification testing and breakdown situations. He leads the implementation of various standards like API 6A in the whole organization. And being a technical leader, he wears the hat of mentoring and training young engineers in the product design area. Mahesh is a leader in this space that he has 16 patents to his credit. He, in fact, is an authority on API 6A and NACE and other standards in this area. His area of expertise is in development of wellheads, hangers, multi-bowl, high-pressure gate valves. These products, as we were talking about, are really complex, operate under very severe conditions, 20,000 psi, 450 degree Fahrenheit. They also handle very reactive agents and media. So these are real complex products. So welcome, Mahesh. I can promise you after this long introduction, you will do most of the talking.
Thank you.
Welcome and thank you very much for kind of agreeing and spending your time to be here. Without much ado, to just kick off this chat straight away, uh, I might not have done a great job in explaining the kind of products that you handle. So it would be good if you are able to provide a view and overview of the products that you are responsible for, and what are you seeing in terms of trends and challenges that you are facing going through today, Mahesh.
Y- Yeah, thank you, Sundaresh, for that great introduction. And good morning, good evening, everybody who has taken time to join and watch this talk. And Sundaresh, to give you just an idea of what type of products we design, my team designs a product, something called as well completion equipment. And when you typically drill a oil well, the depth of the hole can easily be more than 1 mile. So after you drill that hole, and then you have to case it with a pipe. And when you hang a pipe that is about 1 mile long, it has to be supported somewhere. So our equipment helps you to support that long length of pipe, and also to produce the hydrocarbons in a controlled manner. And these hydrocarbons can have pressures up to 20,000 psi. For people who are not do not know what it is, I'll try to give you paint a perspective. Normal tap water that is coming in your house has about 40 psi pressure. So these equipment handle pressures that are about 500 times the typical pressure you see in the household taps. And another example is the water jet cutting. So when we cut thick steel plates, the typical water pressure used to cut that plate is about 2500 psi. And you can see that this pressure even multiple times of that. So very high pressures and very heavy loads. And added to that, the criticality of the equipment. Some of the equipment, once we install on the well, you cannot get back to them. So that means if it fails, that will have a very serious consequence for our customer. And also a very simple very moderately producing oil well, downtime can cost easily up to 300 to $400,000 per day and upwards. So the criticality or the functional uptime is very important. And you might have seen the oil prices, and some of you might have enjoyed the drop in oil prices at the gas stations in the last year. Oil prices have dropped about 21% in 2020. So that puts a lot of pressure on the producers, and we feel the same pressure too. So there is a continuous push for us to provide equipment that are better performing, giving the customers a high uptime, and cheaper. And the expectation is to make them in a record short times.
Yeah, Mahesh. In some ways, a challenging product. And now the expectations are even higher with COVID. So, with these kinds of increased challenges, what is that you and Baker is doing to kind of overcome these challenges? What are some of these best practices? I think some of the listeners today will greatly benefit from some of the experiences that you can share, Mahesh.
Sure. We use many tools for us to help improve the speed and reduce the cost of product development, and I will talk on a couple of them. First one I would like to mention is virtual validation. So basically, using the analysis power of the computers today to in lieu or to aid the physical testing of the products, and we use this virtual validation in two different scenarios. One, we use it as a tool during the product development. So as we are going through the different iterations of the product, we also on the side subject the product virtually to the qualification testing and see how it behaves. So that helps us to come up with a final product which can go through the physical qualification testing much faster than it would be otherwise. And today, this virtual validation has become part of the DNA of product development. So every product that we develop basically goes through the virtual validation as part of the design process. And over a period of time, we have accumulated sufficient amount of data from physical testing. So what it helps us is to tweak these virtual analysis models, right? So otherwise, your virtual analysis is just a uh, computer run analysis with little correlation to the physical testing. So by tweaking it and matching it to the virtual models to the physical test, our confidence in matching the behavior of the part between the virtual behavior and the physical behavior is very high. So that brings me to the second way in which we use the virtual analysis. That is, in some cases where we already have the proof of physical testing, customer or we may need to make some changes. It could be in terms of changing the material of construction or changing the dimension. So in such situations, what we can do is take the virtual model and make sure it matches the previous physical test that we did, and then make the necessary changes in the virtual model. It could be like, for example, material change, and then run the virtual analysis. And if the part passes the performs well in the virtual analysis, then that is taken to be the proof of physical performance. And we have done this many times, and there is acceptance based on the correlation of the data. There is acceptance of this practice, so that helps us to speed up the product development, also save the cost without compromising on the quality of the product. Second tool that we use is a wave, which is value analysis and value engineering, which is a should cost tool. That is, you have the product, and then you do cost estimation based on the fundamental definition, material, process, etc., and then find how much it should cost. So you can use that as negotiating or evaluation tool during the procurement process. But one thing I would like to say about wave is, um, the cost that you come up with is just a snapshot in time. So you need to reevaluate the products periodically, just to make sure your cost information is up to date. And one of the interesting experiences we had was, we had put a good product but considered to be very costly a few years ago. And in the later cycle, when we redid the wave analysis, in current markets scenario, it came out to be well ahead of some of the other slightly products that had slightly less number of features. So we had to take that and start making offer of this better product, which both helped us as well as the customers. So customers were also happy to use that product. So that is one of the things, interesting things that I would point out in the wave of analysis. Third one, we do not so much of engineering exercise, but part of the sourcing exercise is evaluation of the best cost countries. um, the name, the title of the best cost country keeps moving around the world. That is, once you take any best cost country, maybe it is China, as the capacity starts soaking up uh, for any given product, they no longer are the best cost country. That title might move to another country in East Europe or West Europe, or it might come to United States. So that's a constant exercise we do in order to keep track of where the best price is.
So what I hear you, Mahesh, on the virtual simulation is it has become more pervasive. You do multiple iterations virtually so that you can evaluate multiple options. And since you have matured the correlation between test and the virtual simulation data, you now are able to very reliably use it, and hence you can crunch the time, you can save the time of the physical test, and hence that's become a very robust tool for you in terms of now today using it for evaluating not just a new design, as well as you mentioned something which changes from the field. And on the value engineering side, I think your learning is continuously evaluate something which didn't work out at some point in time, could resurface and become a viable design because certain things have changed. Possibly the volume has changed, some cost of production has gone down, and things like that. And hence, you found value in reevaluating and trying to see what other options which didn't work can possibly become
Correct.
useful. And the last third, which on the best cost country again, you're saying what is good today can be not good tomorrow, and hence you need to continuously evaluate. And with these techniques, you are able to really bring the product cost down and ensure that you are continuously improving in these parameters. That's what I kind of wanted to summarize for some of the listeners, because that's how I kind of synthesized what you said. Going on from what you said earlier, Mahesh, in terms of, see, downtime is extremely costly in your industry and some of the things that you do. So, given that, I just wanted to check, is additive manufacturing relevant? Have you guys tried? Has anything worked? Has some things not worked? Because that would be a very valuable perspective for some of us and the listeners, Mesh.
Yeah, yeah. So you summarized it very well, and thanks for that. And with regards to additive manufacturing, we are only talking about the metals because non-metallic like elastomers, rubbers, it's not a no-brainer. But when it comes to metal additive metal manufacturing, it does offer advantages because some of the parts that we do with uh, today's conventional manufacturing methods, we take out as much as 50% of the weight. We start with a very big bar and then hog out everything. So, and when you make the parts out of costly material like nickel based alloys, so you can see the obvious cost saving benefits. And another savings is the time. Right, and we have used the additive manufacturing methods in limited application in load-bearing components and service tools. Actually, it started off because the delivery time given by a conventional manufacturer was not acceptable to us. It did not meet our project delivery deadlines, so we had to reach out to the additive manufacturing vendor, and which who was able to meet the delivery time that we were looking for, and also incidentally the part ended up to be about 10 times cheaper. But and also we keep getting offers from the additive manufacturing suppliers about the cost and delivery advantages. But here is a kicker, right? um, the way to physically evaluate the parts and guarantee the physical properties is still not clearly defined. What I mean by that is, if you were to use a conventional manufacturing method, like for example, forging. So let us say you are making a component and then you forge 100 of them, and then you can sacrifice one of them to find the physical properties of, whereas that is not practical in additive manufacturing, because every time you make only one. And also today's additive manufacturing methods, there are several of them, different ways of manufacturing. So that poses the number one challenge, that is, how do you guarantee the physical properties of the component that you're going to use? And number two is evaluating the behavior of the metal in hydrocarbon environment, because hydrocarbons carry several corrosive gases and even deadly material like H2S. So we need to know the behavior of these additively manufactured components before we can put them in service. And today, the international standard bodies, for example, NACE or API, have not yet recognized the additive manufacturing method as one of the acceptable manufacturing methods. And they are working, actually, they are currently in various stages of developing standards. So it will take time. Um, and they are working on it. And the last disadvantage or last drawback I would like to talk about is size and surface finish. And the additive manufacturing method seems very attractive for products that we make, which are very complex in shape. Um, but the last time I evaluated, there were no machines that existed to make the products to the sizes we wanted, tolerances we wanted, or the surface finishes. So we are keeping a close eye on that, both in terms of the evolving capacity and also the evolving scenario on the international standards.
In some ways, Mahesh, what you're saying is you have tried and it has worked in certain things. You continue to see there are certain challenges which still have to be surmounted, and with that, possibly you will be able to leverage it a little more higher. Do you see a promise in the future for additive in your area?
Absolutely. Absolutely, yeah. Actually, this week and next week, API is meeting um, to see the status of development of standards, and this will be one of the standards that we will keep a close eye on. And Baker is participating in development of this additive manufacturing standards, and we also keep a very good capacity in house to make the additive manufacturing of our products.
Sure,
I'm
Mahesh.
pretty sure this will offer advantages. We just need to address some of these issues.
Okay. I think that provided a good perspective. Talking about another latest trend in the industry today, there's almost extreme automation. There is a lot of move towards autonomous. If you look at the definition of Industry 4.0, it is all about trying to see how factories can autonomously work, a lot of focus on autonomous cars and things like that. So is there a relevance of this technology in your space? If yes, then where do you see it? Have you guys done something in this area?
Yeah, there are several applications or several points I can talk about for the autonomous management. And one of the interesting applications that we are seeing is the unmanned platforms. And what this unmanned platform is, I just like to give a perspective. There are a lot of small hydrocarbon formations dispersed around the world, many of them offshore, and the amount of hydrocarbons that are held in these formations, it does not make economic sense to go and develop a full size platform. So what the operators are looking at is developing a very small platform where what you all you have is a completed well, and it is producing the fluid and diverting that fluid to some other location where you can further process it. So in such applications, the demand on the product increases tremendously. That is number one. You cannot ask somebody to go and periodically grease the product. So that means your product should be capable of working without any service for a considerable amount of time. And number two, that is, if your product fails, there is nobody around to quickly get to it and fix it. So the interval mean time between failures needs to be very long. And some of the applications what we are seeing, customers are demanding us to supply products which do not require maintenance for 3 years, 5 years. They should continuously operate without requiring any kind of maintenance, or not, nor does it go through any failure. And second one is no maintenance throughout this period.
Okay. And how do
And
you monitor this, Mahesh? How do you monitor this remotely? Uh,
so,
it-
that drives into automation and embedding more signals or more sensors to get the condition of the product, so it can be monitored remotely. And there is also a second push, because having hydraulics on these remote platforms means there is more components and more opportunities for failure. So there is a push for going for all electric automation.
okay.
So this drives into increased more rigorous product qualification, also the new product qualification testing, where we are making progress to be prepared for this opportunity. And also what we are seeing is the drone surveillance.
Okay. So, Mahesh, what I hear you say is autonomous is, in your context, an unmanned rig which can become economical, but that has got impact in terms of how you design the product, how you make it more reliable, how do you actually continuously monitor performance, wherein you can use the IIoT kind of technology, and then possibly do drone surveillance to ensure things are in operation. So in some ways, when I asked the question, was thinking in oil and gas, possibly there is less relevance, but you were able to kind of bring out a case where this is looks extremely relevant and it's going to make it very economical. Moving on, Mahesh. See, in my view, product development teams being co-located, operating out of one part of the world, is all moving away and is moving towards globally dispersed teams and a ecosystem of partners involved in developing a complex product. So, what has been your experience? What has worked? What are some of the things to watch out for if somebody is venturing into this global development of products? And what would be your advice, and what would be something you see in the future in this area?
Yeah, thanks. Uh, Thanks for that great summary. And for the working with product development with a globally dispersed team, the first advantage that comes to my mind is faster response time, because uh, it helps you to follow the sun. That is, once you do whatever you are supposed to do, you hand it over to the next team and they continue working on it around the clock. And of course, to have a well integrated team, you need to do the homework. That is, you can't turn on the switch and tomorrow you have a global team. You need to develop that relation and work together, understand each other, and also understand the product and jargon, um, and also the expectations. The communication has to be very clear when you especially work in the global dispersed team. Brings out a lot of advantages, because different people from different region can bring you a alternate perspective. And in one of our experiences, when we were working with the dispersed team, we were able to bring in people with much more mathematical capabilities than what we had in our local team. So that helped us to complete some projects tremendously. Baker Hughes has teams that are dispersed all around the world, and also we work with partners such as yours. And another advantage, or what I can think about on a dispersed team, is leveraging expertise in the niche areas,
Okay.
which is like a shared expertise. And this requires hard work upfront, and Baker has done that. And with hard work and the time investment, you will be able to use the advantages of the global team. And look, today developing a product with people located in single location is not possible,
Okay.
because just that expertise and also the time expectations from the customer, you have to have a global presence.
Yeah, Mahesh, that leads to what has been the impact of COVID when you're already in a global dispersed team? So, uh, did things work out well? Did it make it worse?
We were ready, because Baker Hughes, we have historically been executing the products or the projects for one region or another. So we were ready. In fact, when the COVID hit, I would say it was as if nothing else happened. We continued to deliver, and in fact, our teams were so impressed by the delivery. We don't have a plan for going back 100% to an office. So the company is now encouraging people to work from home.
So, in some ways,
Yeah,
even the local teams have, in some ways, become a little bit dispersed. And you are
right.
saying because you had done the homework, done the hard work of creating that the collaborated, integrated teams, you had minimum impact. Possibly, it even improved a little bit in these kind of times. So
Yes.
Mahesh, I think we covered a lot of ground in 20-25 minutes, and for the depth of knowledge that you hold in some of these areas, possibly it will need a day's session for you to really articulate the various experiences that you have. But in the interest that we cover little more broader topics and help some of the so some of the professionals in product development get some of the insights into what are some of the best practices. I think I would say you have been able to articulate extremely well on some of the things. I really enjoyed this because you really brought out the things as they are. You said these worked, this didn't work, and when it didn't work, you said this is the reason and this is how it needs to be done. And then when you also something worked, you were very carefully, you went behind the scenes and said it worked because these are the things that was done well. So it was extremely insightful to me. I'm hoping it was very insightful to the audience here. um, Thank you very much for spending this time. If you have any last comments, if you have anything to kind of add on to what we discussed today, welcome, Mahesh.
Yeah, we talked about the new. Just to summarize, new trends, new trends are the current ongoing trends, the simulation, and then additive manufacturing. These are the some of the places for the product development professionals to pay attention to, and uh, definitely, if you are not doing a global collaboration, you should consider doing that. So, with that, I want to thank you for spending time to talking with me, and uh,
In
and
fact, Mahesh, we are indebted. We thank you very much. Have a nice day, and hopefully, we will talk some other topics sometime in the future.
yeah,
Have a nice day, Mahesh. Bye.
likewise. Thank you. Bye bye.